Oh, to the automation celebration last night, which was what AI cannot do. We had some incredible food, but the acts were awesome. And I want you to know that there were three sisters. Their group's called Sorel, which means sisters. And they were the runner-up in the U.S.'s The Voice last year. And we had this French beatbox group called Berry Wham, which everyone loves. And it was great. And the bartenders were making sort of drinks and juggling bottles, and it was everything was entertaining, even the food.
So our theme should be AI. This doesn't work as well. Yes. Yeah, I mean, I think for me, well, my feet hurt, which I think is because of all the walking. I'm not sure you all feel the same. But I went to a lot of sessions yesterday and walked around. And I think, we wanted to really bring the customers forward here. And I hope you all saw some amazing customer stories. I'll give you a few of what I saw. Well, first of all, my favorite one was Sam Balaji on stage yesterday with Rob Enslin from, Sam from Deloitte. But he said he committed to 10% of the Deloitte workforce becoming trained on the UiPath platform. Do you know how many employees Deloitte has? Over 450,000. That's amazing. And that's really cool. But that shows that you can what our technology is all about. And certainly there are many other partners here who are equally committed. And so I don't want to not highlight them, but it was really fantastic what Sam said. But then, Cathay Pacific from Hong Kong and British Airways from London, they were talking about AI work, in these amazing airlines, VMware and Paychex. I saw them talking a bit about their views of what are their top four priorities, top four features beyond RPA. And then one of my favorites, not because I happened to bump into them early because they were practicing and they were really working hard and they know who they are here, but I had to go see them. And that was Nicole Otero, who runs the Department of Navy's Automation as a Service COE, and Rebecca Young, coincidentally, also from Deloitte, she's an AI SME. And they gave deep advice on how they're taking automation across all of the Navy and transferring government. So look, there's many amazing examples, Barry, but those were really highlights for me.
So today we have more breakouts starting at 3:30 and also the industry summit this afternoon. So make sure you don't miss those. The keynote theater this morning we have the digital economist from Stanford, Eric Brynjolfsson, and Bobby will wrap that one up with Eric asking. Eric wants to have questions. So we want you to go to Expertsville after the AI 10 awards this morning. That's what's going to wrap this morning's session. But speaking of questions, please bring your questions to Expertsville. We have assembled the world's best UiPath experts there, and we want you to try to stump them with your questions. So please do that. And then the day we wrap up today with the unwind happy hour in Expertsville at 5:30. We'll have a drawing for the fast forward game that you can play. Check out your mobile app. But we should.
Yes. Well, speaking of the best experts,
yes,
we would not have gone from RPA as a tool to automation platform to AI at work without these three amazing amigos, the trio.
The trio.
And every one of them out, he's our head of AI strategy. He'll kick this off, Dr. Ed Chalice.
Wow, it's amazing to be here at the beginning of day two of this incredible event. And what I really believe is actually kind of the beginning of a new era, the era of AI. And I think all of us, in 5 and 10 years, will look back and say 2022, 2023, those were the years when this kind of things really started to change. And so I wanted to take this opportunity to kind of facilitate a conversation about where we're at in AI, how we got here, where we're going, and kind of what we need to do collectively to make this future a positive one. So to have this conversation with me today, I'm joined by two amazing colleagues. Firstly, Professor David Barber. It's great to be here. So I've been working in AI for about 30 years now. I think. I actually went to had some AI researcher. I had the UCL AI Center in London. But I also work here at UiPath. So we have an amazing AI research team here at UiPath. We're working on some of the most amazing, impressive technologies I think that we're going to be seeing in the next months and years here in the products that we make as well. So I'm super excited about AI. It's come a long, long way in the last few years. So we're going to talk about that. Obviously.
Amazing. I'd also like to welcome Luke Palamara to the stage, our VP of AI Product Management.
Hi, everyone. I'm Luke Palamara. I lead AI product management here at UiPath. I've worked my whole career shaping enterprise products with AI, including a decade at IBM Watson. But here at UiPath, I really see my role as creating this fusion between AI and automation. And, Ed, I think the AI landscape has never been more thrilling to navigate than right now.
And I'm their cellist. I head up AI strategy, and I kind of think of my role as somewhere between you both. So, my career has been a mix of AI research and building kind of new AI products through the startup I founded. And I kind of sit between your team, who's developing the new models, these new cutting edge kind of capabilities, and the product managers and engineers that make it real in the platform for our customers and our partners. So I kind of wanted to start my session, with the professor, with you, David. I'm going to give you the difficult task and try to explain, where are we in AI? How did we get here? How would you kind of summarize that?
Yeah, thanks. I mean, it might be good to go back a little bit in time and think, what was the initial goals of the field? So actually, AI, you may not be aware of this, but it's not really a new thing. It's been around for at least 50 years. And actually, the ambition's always been to make these systems that can do things like humans can do, there's tons of tests. And it's actually, in some sense, a very inspiring message. That's been a hopefully vision for a long time. In some ways, it's actually very well aligned with the UiPath mission, right? So there is a human achievement. It's a really similar kind of goal. So there's no coincidence, and in some ways, we've seen the convergence of these ideas that UiPath and AI. And I think actually, it might be good to think about the ways that you can try to do this. So there are different ways to try to achieve this goal of AI. And actually, some of them are very logic-based, right? So they're playing games like chess, etc. But the other way to do it is to try to replicate the way the human brain works. So this is called like an artificial neural network. So in our brains, we've got these billions of neurons and we're all interacting and connected in complicated ways. And the idea was, could we build a system like that? The idea was, well, it might make sense because if you can build a system similar to the human brain that's actually constructed, maybe it can solve similar problems like humans can do, right? So we really like to do that kind of processing that brains can do. But actually, that's also a very complicated thing. We've got so many of these neurons, and how to connect them is a very complicated problem. And the amount of compute you need to actually do that, the amount of data you need to determine this connection is actually very, very difficult. So whilst the field's been around a long time, it's only relatively recently that we're seeing accelerated progress in the sense that we're actually systematically. And if you look a little bit at the figure here, this is an interesting graph, I think, where you can see this, from 1998 to the left, we started to document how well we were doing against humans, an average human level. So on the vertical axis, you can see the 100% human performance at the top. And the top, the most left one is things like handwriting recognition. So you can see that actually over time, steadily gets improving. To the point where maybe around 10 years ago, actually the systems are now outperforming humans. So these are the neural network, artificial neural systems. And then we sort of looked at other specific problems as well, like say speech recognition, image recognition. So for example, like giving an image. Is there a cat in this image? Or what is in this image? So the machine has to recognize that. And you can see that again, the things
went well. Things were going quite progressively good until around 2012 to 2013. Things really started to accelerate very dramatically. At that point, there's the introduction of GPUs into the whole game, right? So this is a really major thing because the amount of compute power that they have is huge compared to what we had previously. It's actually quite difficult to comprehend this. So we are used to every year the computers get a little bit faster, like 1.5, 2 times faster than previously. This compounds, and even though the artificial neural networks at the time were very similar to what was proposed 20 years before, in 2012 there were thousands of times faster to the point that basically it would have taken 100,000 years to train that system 20 years ago. That state-of-the-art system. Now, actually, it would take over many millions of years to actually to train, say, a large language model. I can say this the hardware from say 24 years ago. It's actually that level of solution. We're not really conscious of it. It's a major thing. So you can see that we've done really well with each of these individual tasks. Actually now it's pretty much, if you've got enough data, you've got enough compute, the computer will always be the average. It's really at that stage. Every single one of these tasks has been knocked off. And in some ways, that's only part of the story. These are perceptual tasks. The machine is perceiving the world, it's recognizing objects, it's recognizing speech, etc. But that's the kind of, that's only one half of the story that we can tell these. And what we'd like to have is something else. We'd like to generate things. So humans actually are also very good at creating. So in some ways, we'd like to have that ability as well. So we start now with some very specific tasks, again, like say generating completion of a sentence, or say generating maybe translation from one language to another, or generating some code. And these are all quite good, quite reasonable. You can see again on the graph towards the right that because of the compute data, the amount of time it took to exceed uniforms actually was going down. But then around 2019, 2020, you have an amazing idea, crazy. So what happens if we now try to take maybe a huge chunk of the internet and try to just make the model generate the next, say, word in, say, sentence, or rhyme sentence, take it from the internet, given the previous sentence. That sentence could be a language, it could be code, it could be anything, it could be all kinds of stuff. And the amazing thing is that actually, surprisingly, these systems, if they've got enough data, they learn all kinds of incredible facilities. So not just to generate because of code or to complete that sentence, but actually to do things like logical reasoning, is to some degree, to understand much more about our rich cultural heritage. Because a huge amount of the linguistic information of humanity is actually being ingested by these systems. And actually, that's really not a very, very powerful thing. So it's really, I think, one of the most inspiring things that's happened in the last, say, 10 years, 15 years in AI. And these are some really, really, really cool. And they're very creative. So the good thing is they're kind of like built like a human brain, right? So they're good at cognitive tasks. The bad thing is they don't like human brain in the sense that they're also fallible. It's hard to interpret. You can actually make mistakes like this kind of time.
Well, this, to summarize 70 years of research, I guess in 4 minutes, it's kind of amazing. But, definitely we've gone from this transition of AI just being a kind of perceptual kind of classification engine into being something that's much more creative, generate, text, code, and, super fast and all underpinned by this incredible growth of compute. But, from, great kind of fundamental perspective, but in the world of business, Luke, how would you summarize where we're at with this technology and specifically kind of generative AI?
Yeah, so as things stand right now, Ed, in the world of at least enterprise AI, things are kind of bifurcated. On one hand, we have these specialized models that are highly tailored and specific, and they're trained on these narrow domain-specific data sets. And specialized models have these traits like being really fast, they're predictably good, they're relatively inexpensive to run, and they have this detailed understanding of data that's really important for businesses, like being able to understand things like invoices, bills, receipts, being able to extract information from those. But the challenge comes in that these documents can be nuanced in different kinds of ways from company to company and from use case to use case. Things like the language in them, the visual layouts in the documents. And so specialized models can be trained to understand these nuances to get the highest level of accuracy. And actually, some of the hidden cost of specialized models is this training if you don't have the right or proper tooling and methods to really make them specialized enough for your use case. Then on the other hand, we have these large language models, which you were sort of alluding to, David, which are based on these massive corpuses of data, and they power generative AI today. And generative AI, of course, promises vast capabilities, but today it's largely relegated to improving personal productivity. So, for example, it's great at writing tasks like summarizing information. It can analyze data quite well, but it may or may not be correct. And it is limited when it comes to very domain-specific type of tasks that are so important to enterprises. But really the future that we're all working towards and the future that we all want is AI actually doing work. It needs to go beyond just this personal productivity. Otherwise, its potential becomes somewhat capped. And so AI has to do work. This is the biggest difference between personal productivity and really enterprise productivity. So, for example, if your company could hire just an aide that could advise but not actually do work, like how valuable would that really be? So we need AI that doesn't just advise, but actually undertakes tasks. And that's really where the frontier lies. It lies in this transition from personal aids to really enterprise catalysts for AI.
Well, yeah, I think that's really clear and kind of helpful way of breaking it down. This personal productivity tool versus this kind of enterprise productivity tool. And I like that expression. Kind of words are cheap. We need to actually do stuff. So I guess kind of could you try and summarize like what are the pieces we need to put in place to get this technology into a place where it's actually doing stuff for us? Like how can we make that real?
Yeah, I think there's really three critical ingredients to make AI really productive in the enterprise. They're context, action, and trust. So first, we can tackle context, right? So AI is really only as good as the information that you give it. Just on this stage yesterday, we had Walter Isaacson, who's an amazing author. I'm actually a really big fan. I read many of his books. But would you go and hire Walter Isaacson and on day one put him in front of your contact center or on your help desk and have him answer emails to your customers? Well, he's an amazing writer, has incredible writing capabilities, but he wouldn't have the information about how to respond to customers. They're based on the historical conversations that your company has had with them or interactions, or know what type of level of service that this particular customer needs to be provided based on their status, or know how to actually take the request that they're asking, like upgrading an insurance policy or canceling a policy, and knowing how to actually get that work done. So generative AI similarly has this need for context, where to enter data, what to look for. And in the UiPath platform, this really comes together in our integration service that creates this bridge from the context that's locked away in the data sources, and being able to pull that data in and feed it to the AI so it has the context so it can get things done. And then next, this one's really critical, is action, right? So what good is knowledge if you can't act on it? Benjamin Franklin, who was actually another subject of Walter Isaacson in another book, Benjamin Franklin said, "Well done is better than well said." And I think that's really true for AI as well. AI needs to do more than just generate text and images. It needs to move data flawlessly from system to system. It needs to be able to respond to customers based on, again, historical interactions that you've had with that customer in the past. And it needs to be able to know how to place an order when inventory is low. So this is what UiPath really is all about at the end of the day. It's about putting AI to work. It's about bringing this rich set of capabilities that allow AI to take action and not just be an advisor. And then I think the third, but certainly not the least thing here, is around trust. So leaders really want to embrace generative AI and really all forms of AI, but they're wary of the risks. And I think that's like really well reflected in a poll that happened last year that was run by Pew Research, and that 38% of people in the general public in the United States were more concerned than excited about the use of AI. And then the same poll that was run again this year, and it went from 38% to 52%. So for enterprise leaders to adopt AI, they need to trust it. There's obviously a lot of issues around trust right now, and there's a lot of ways to tackle that. We can talk about how we unpack the trust issue.
Yeah, I mean, that context and action piece is very clear, right? But trust is the foundation. If we can't trust these systems, if we can't get buy-in, if we can't validate them, ultimately we can't use them. And so I kind of want to just like focus on that trust problem. And it's something I think about all the time. It's something we all think about at UiPath all the time. We really see kind of three core challenges there, three core kind of questions. The first is information security. So you might all have seen these stories where, someone's query into a GPT model got leaked to another user. That's absolutely kind of critical. We've also, everyone's kind of aware of these issues around, just as you were talking about, I like the idea of getting utilizing to run your payroll, imparting specialized knowledge, and how we can make these tools, have the kind of the lingo and the knowledge of our processes and exceptions. And then obviously there's that hallucination question that comes up in almost every question, in every conversation. So, we're working super hard to address all of these. And, that's why I think it's, so great to see, one of the Graham's announcements yesterday around the AI trust layer. This allows, all, UiPath users to get that kind of governance, control, visibility on all of those large language model tools, complete visibility, filtering, and all of that control in a CISO and a CIO demand around that. But if we kind of move on to some of those other questions, I wanted to kind of think about imparting specialized knowledge on these systems. Really kind of there's two ways there, right? One is to give a really great, accurate prompt, which is the context piece. UiPath is clearly super strong at getting that information into the LLM. But the second core tool there is fine-tuning these models, giving them kind of specialized information. Fine-tuning models can be expensive, but active learning is a really amazing tool to make that super fast and efficient. I was wondering if you could kind of take a moment, David, to explain the whole concept around active learning.
Yeah, sure. Thanks, Ed. So maybe it's good to think about traditionally how are these machine learning models in AI systems trained, right? So they're typically trained on the basis of labeled data. So if you think about, for example, making a system that can recognize a cat, then you have lots of images where the human was saying, well, that image contains a cat, that image doesn't contain a cat, etc. And all this time manually labeling these images. Then you give these pairs of images and labels to a machine learning algorithm, and after some time you come up with hopefully it's good at predicting whether cats are in an image or not. Fine, but that's a lot of human labeling effort. That actually has become probably the biggest bottleneck actually making these systems work. But in active learning, you can do it a little bit differently. It's a smarter way to make use of your human labeling effort, your employees and your company's time. So the system actually, once it's seen, say, one or two labeled cats, non-cats, actually it's already started to get some sense of what's a cat, right? So maybe when you show it a new image, it might say, well, look, I'm very confident this is actually a cat. I don't need a human to tell me there's anything, right? But this thing here, dog, I've got no idea what it is, never seen anything like that before. And it asks the human to step in and tell him if that's the cat or not. So in this way, actually, the machine then, every time it gets a label from the human, it again updates, right? And then it increases its knowledge, in this case, about a cat. And that means that the overall amount of labeling effort required for the system to converge to a very good cat classifier is actually much lower than it would have been if you just labeled 10,000 images of cats and non-cats to start with. Maybe you could get away with only 1,000 or less. And so in a similar way, in this figure here, you can do the same kind of thing for documents. And if you want to train the system which can do accurate, say, document classification and generation, if the machine is very confident about doing that case, it just outputs the thing. If it's not confident, it passes it off to a human and says, well, can you actually help me out here? Can you give me a label for this thing? The human gives a label for that. The machine then recalculates it, recreates its own parameters, learns more, and the process repeats. And actually then each time it starts to improve very quickly.
Yeah, it's almost like I view active learning almost as a kind of a conversation between two colleagues. You know, you only ask questions about the things you're uncertain. You don't ask the same question again and again and again, which is why so much kind of using AI systems is often so laborious when it doesn't have that AI, you know, that active learning component. And then, you know, I think one of the hugest components, you know, tools in our tool chest, so to speak, to bring, you know, safety and governance and control to the use of this technology is obviously human in the loop supervision, human in the loop review. And I wonder if you could kind of talk about that for a bit.
Yeah, I really think that the human in the loop capability is one of the most important capabilities when it comes to, you know, making enterprise AI really productive in businesses. So one of the misconceptions about human in the loop is a lot of people think it's just about correcting errors, you know, in from the output of the AI, inserting a human to review it, correct errors. That's obviously a critical part of it. But it's really also about creating trust. And coming back to the trust topic, it's about, you know, bringing oversight and accountability within AI processes. And, you know, it's also about reassuring stakeholders that AI decisions can be validated, they can be checked, and they can be overridden if necessary. So in the UiPath platform, it's really Action Center is where this all comes together. It's sort of this hub that enables humans to sign off and approve AI decisions.
Amazing. Well, I think, you know, we're almost at time, so just over to the professor. Where do you, I guess, what are your predictions?